Hello, Mr. Mang and Chanel. Today, our team member are pleasure to give you the presentation about the programming project called Huffman compressors. And before implementing this presentation, we introduce our team member. I'm Project-Quang, and here is our partner.
Hello, my name is Huffman, and our presentation follow at the outline. So firstly, introduction, we will introduce the general information of the Huffman compression.
And secondly, project overview will provide you with some very general information, something like our main task or difficulty level.
On the working process, we will talk how we make the plan and how we work together to carry out the project.
And in the coding explanation, I will explain for you the code in more details, how we approach the problem and come with the idea to make the code.
And in conclusion, we show the more useful feature of Java that we learned from the project.
So before conducting the project, I have to know what is the Huffman compressor, right? So the Huffman compressor is the program that classified using Huffman coding scheme. The Huffman coding scheme is the scheme based on the frequency of the characters. The basic idea here is that instead of using 7 or 8 bits per characters, we only use fewer bits for the character with larger probability.
In our project, our overview, our main task is write the class the Huffman tree, and the code includes 8 methods. The total number of the lines is the 61 lines, except for the line of command, and the average length of lines of each method is the 7 lines. In our viewpoint, the rate of project is quite normal because the manual is really clear. It gives us the hints and the way to show the problem step by step. As we have sufficient knowledge to complete the project with the supporting file and the manual.
So here is our working process. In fact, before conducting this project, we have to make the scientific plan for working schedule to improve the efficiency of the result. Specifically on Thursday, we spend 5 days on working projects from Thursday to Monday. On Thursday, we try to read and understand the Huffman compressor problem and the sorting file. So I think this step is very important. It will take a lot of time to have a thorough grasp and comprehensive understanding about every part of the project.
On the Friday, we work together and get a general idea and algorithm for each specific part. And then we try the procedure for each part.
So it's next day on Saturday, we work intuitively, start coding each part, and also we share the code through the internet. And I'm Nam, and I'm responsible for part 1 to make the code, and Kirk is undertake the part 2, encode and code file.
On the Sunday, we combine the 2 codes of the 2 parts, and we test and tweak the program. But in fact, we make a lot of difficulty because the many different courses, and we must read again the manual more carefully. Finally, so the mistake has been shown during this day.
And on Monday, we continue to test and fix the code and optimize the program so that the length of each method is as sorted and clearest as possible. Then we put the method, put the command for each method. Finally, we discuss as to how to write the reports and answer all the questions in the presentation by us. Code explanation. Now we move to the code explanation. We will explain our code and algorithm in detail here. As you can see, here is the data field. It has one variable type Huffman node. So what is the Huffman node? Let's see the Huffman node class. Huffman node is another class used to define a specific node. And especially, it implements the comparable interface type Huffman node in order to make a node comparable. So these four lines did show four data fields inside the Huffman node class. Firstly, ASCII to store the ASCII value of characters. Secondly, flag to store the value of frequency. Thirdly, 0 to refer to the left subtree. Finally, 1 to refer to the right subtree. The next one is used to construct an empty node. And these two methods are to construct the leaf node of rank nodes with the given data and links. More importantly, this comparative method describes incompatible interface is used to compare the ordering of one node with another one depending on frequencies. So let's move to the main parts. The part 1, make codes. So the first method is the most difficulties method. So the method Huffman trees is the method with array of frequency parameter that is used to construct initial Huffman tree. It is also the most important one. The first thing we have to do is to create an empty periodic key. It is used to store all the Huffman nodes increasing order of frequencies. Then we put on those nodes by using for loop. Inside the for loop, if the frequency is positive, then create a new Huffman node with index 1. Index I is the ASCII value and count I is the frequency. And then add this node to the periodic key. After the for loop, we build a special character called identify with ASCII value of length of given array, and its frequency is 1. And also we put it into periodic key. So we already got the periodic key store nodes in necessary order. The next step is to build the tree from this data structure. And the build tree method is used to do that. We use while loop with condition that the size of key is greater than 1. Then inside the loop we do following things. Firstly, we remove two lowest frequency nodes and combine into a single node whose frequency is the sum of two previous ones, and put back parent into periodic key. So after all, we got a special binary search tree named Huffman tree.
Now, let's go to the easiest part of program. The algorithm is definitely similar to the method right of guessing game project. We just use the simple recursion to show it. Write method is used to write tree the given output stream in the standard format. The first line is ASCII value of the character stored in the list. The second line is the code 0 and 1 for the character with the ASCII value. For example, inside the source code, 105 and 108 are ASCII value. 0000 and 0001 are the codes from Huffman string. Let's see the picture. From the top of the tree, we write the left subtree until reaching the list, and write the ASCII value, then write the right subtree. Now come back the code. This method is called write method with 3 parameters: overall, row, output, and refit. Next, this write method recurs to tree to the right out. The base case is the node in the list, then write is the ASCII value first and write the refit. If it is the branch, we record the write method of the left subtree and refit plus O, then write the right subtree and refit plus 1. After making a code in the part 1, let's begin part 2. Encode and decode the file. Reconstruction the tree from the file that is the output produced by write method. We reassign the overall row to the new empty Huffman node. As you know, the first line is the ASCII and the second line is the code of character. We use the while loop to read the code. Inside the while loop, at first, We need to call next in to read the integer and next line to read the code, but missing token by reading and line by reading is not simple. Therefore, we use alternative method that uses a method called parring in the integer class that allows us to use two successive called on next line. We call the method read code with two parameters, code and value. Firstly, we create a temporary variable to refer the overall row. With every code, we read each bit and rebuild the part of the tree similar to the tree in the past one. You follow to execute this step. Specifically, if the first bit is 0, we have two cases. If it has already the substring, we link the term variable to the next node. Conversely, we build a new empty node. We do similarly if a bit is 1. After reading all bits of code, we put the ASCII value into the last term node.
The last method is the decode method. In this method, we read individual bits from the input stream and write the corresponding characters to the output. It stops reading when it encounters a character with value equal to identified parameter. This is the pseudo identified character. First, create the integer variable to store the ASCII value. Next, use the while loop with condition that ASCII value is different from the identified character. Inside the loop, we use the method write to cast ASCII value to the character form. Then we do the next ASCII value by using the below decode method. Let's see the decode method. It uses recursion to decode for its ASCII value. So the base case here is that if the node is a leaf, we return the ASCII value. Otherwise, reach each bit of input stream and we check whether the bit is 0 or 1. If bit is 0, we return the value of the code for the next left node. If not, if bit is 1, we do similarly for the next right node. So let's do some tests to make sure that this coding makes program run well. So here is the result, and so let's see the sample file. So we see that it's exactly the same, so it's correct. Now do the next test for decode. Code defining. So we see the result, test. So here is the decode. Now see the sample result. So they are exactly the same. The program ran correctly. So after spending time and much effort to try to solving the projects, we draw one of the most useful feature of Java, that is the binary search trees. So the binary search tree, in fact, is composed of comparable nodes. It means that the nodes consist of more than one value, but only one value is used for binary search trees to compare and rank each node into the tree set order.
In addition, the binary search tree is a useful data structure to access and to store the data applied to the project. It's useful to decode and encode a file extremely fast and easily.
So that is a great advantage of binary searches. So thank you for listening and watching our presentations. Have a nice day.
Goodbye.